All right, hello there. This is Mr. Frazier, and we're going to talk about lesson 6.4. And lesson 6.4 deals with our parallelogram family again. So we had all our parallelograms, and we have our rules for parallelograms. Okay. And we had the definition of parallelograms, which was opposite sides are parallel, two pair. And then we had two pair of opposite sides are congruent, two pair of opposite angles are congruent, diagonals bisect each other. Um, two pair of, or yes, we have two pair of same side and consecutive interior angles. Alternate interior angles, we also have two pair of. And last but not least, who can remember the last one? Come on. Look them up if you have to. The last one is a hard one. It's one pair of both one pair of both congruent and parallel sides. So that means the one side has to be parallel and congruent. All right. So after you go to parallelograms, then they break off and you have special types of parallelograms. You have your rectangles. And you have your rhombuses. Now, you used to never be able to say rhombuses. It used to be rhombi, okay? So I switch back and forth every once in a while, but you have both. And the definition of a rectangle, anybody want to take a guess what the definition of a rectangle is? I hope you said a definition of a rectangle is any shape with four right angles. That is what a rectangle is by definition. Four right angles. Okay? And then you have the definition of a rhombus. And anybody want to take a guess at what a definition of a rhombus is? I am hoping that you said four congruent sides. Okay, so the definition of a rectangle is four right angles. The definition of a rhombus is four congruent sides. All right, so you have those two definitions. Of course, you have the pictures that go with them. You have some rules. There's only one rule for a rectangle. Okay? And that rule for a rectangle is that your diagonals are congruent. Okay? And that picture looks like this. So the one rule for a rectangle is that your diagonals are congruent. And that would be AC is equal to BD. Diagonals are congruent. Okay? And that is, by definition, a rectangle. So if you have diagonals, if they say you have a parallelogram where the diagonals are congruent, notice they've given you two things. One, that it's a parallelogram, and then two, they said the diagonals are congruent. If they give you something that gives you a little bit of information, you pick from that family. Now, if they just said the only thing about this shape is the diagonals are congruent, what shape is it? You're going to have to be careful because this could be something else. But if they say it's a parallelogram with the diagonals congruent, it narrows it down. All right? So the wording of the question is where people have an issue. Because if they tell you a parallelogram first, then you know this is a rectangle. But if they just give you this information, you have to be careful. It could be other things as well. All right. Then you have, and that's your only rule for a rectangle. So you have a definition and a rule. Now with a rhombus, you have two rules. First one is your diagonals are perpendicular. hopefully understand that they do this. When your diagonals are perpendicular, that means they form what kind of angles? Right angles, right? So you know the measurement in here has to be 90 degrees all the way around. That makes these right triangles. Oh, right triangles. Wait a minute, Mr. Fraser, could that mean we use sine, cosine, and tangent again? Yes, it could. Right? Could I use Pythagorean theorem? Yes, you may. So it's important to understand that diagonals are perpendicular. Okay, it makes right triangles, and then you can use right triangle rules to find sides and angle measures and all that good stuff. The second thing that happens is that the diagonals bisect all angles. The diagonals bisect all angles. So not only are the alternate interior congruent, but all four of them would be congruent because they're being bisected, meaning it's cut into two equal pieces. So you have the rule, all diagonals bisect all angles, and this rule, diagonals are perpendicular. So you have to understand, oh, here we go. This parallelogram has diagonals that are perpendicular. Oh, I know it is, or could be, a rhombus. Wait, my diagonals are congruent. It could be a rectangle. The parallelogram with diagonals that are congruent. It's definitely at least a rectangle. It could be something else as well. Okay, so you got rectangles and rhombuses. If they were to have a child, their child would be made fun of because they're geeks. A rectangle and a rhombus have a child, it's always a square. Okay, so the definition of a square would be the combination of the definition of a rectangle, which would be 4 right angles, and 4 congruent sides. So in other words, the definition of a square is the rectangle and the rhombus definition in one. Okay? And then proving that it is a square if it had one rule from rectangles, the rule or definition, and it has one rule from rhombuses, one from each guarantees me it's a square. So a square actually has all of the rectangle and rhombus rules. But if you're able to pick out one rectangle rule and pick out one rhombus rule, then you know your shape must be a square. Okay? Now they give this to you as a Venn diagram. Most of you remember what Venn diagrams are. Here's rectangles, here's rhombuses, and then what is in the middle would be your squares. Okay, they give that picture to you on page 397 if you want to see it. Okay, so if you have a parallelogram where the diagonals are congruent, then we're talking about a rectangle. If you have a parallelogram where the diagonals are perpendicular, then you have a rhombus. If you have a parallelogram where all the sides are equal, then you have a rhombus. If you have a parallelogram that has all the sides equal and the diagonals are congruent, you don't just have a rhombus, you don't just have a rectangle, you now have a square because you have one from each. Okay? So that is how we determine. Now that information helps me with angles and sides, Pythagorean theorem, knowing what things are equal to each other, and then I can find length of stuff. So this will help you tremendously in 6-4 as you do your work. Please remember to do the lesson check so you can ask any questions concerning the lesson check when you come back. All right? Have a wonderful weekend, and I look forward to doing another video and seeing you guys back in class on Monday.